Hello, welcome to the HSBA Senior Counsel's Division's Coffee Hour. My name is Jerry Chang. I'm one of the SCD directors. It's my pleasure to introduce today our speaker, Edmar Castillo, Compliance Assistant Specialist with the Hawaii Occupational Safety and Health Division, or HIOSH, Department of Labor and Industrial Relations. He'll be presenting on fall prevention fundamentals for general industry and construction. Edmar has been with HIOSH since 2015 and previously served as Compliance Safety and Health Officer and Discrimination Investigator. In his current role, he helps organizations prevent occupational injuries and incidents by providing practical safety resources and encouraging efforts that exceed minimum HIOSH requirements. So with that, here's Edmar.
Thank you very much. Here on this slide, I want to note that this is the top 10 most serious cited standards that my agency HIOSH cited during fiscal year 2025. And that's beginning of October 2024 to the end of September 2025. Notice number 2 and number 6 relates to fall protections, in which I'll explain shortly. And now for a few announcements. Fatalities caused by falls from elevation continue to be the leading cause of death for construction employees, accounting for roughly 400 of the 1,000 construction fatalities recorded nationwide in 2024. And those deaths were preventable. On this entire week, the National Safety Stand-Down to Prevent Falls in Construction raises fall hazards across the country in an effort to stop fall fatalities and injuries. It's a chance for companies to pause and speak directly to employees and reinforce the importance of fall prevention. And for more information, please visit osha.gov/stop-falls-stand-down. In May 2024, the HIOSH adopted the federal OSHA procedures regarding the National Emphasis Program on Fall Hazards. And this procedure is aimed at reducing or eliminating injuries and fatalities associated with fall hazards in all industries. And for more information, please go to the listed website. And welcome to the Fall Prevention Fundamentals for General Industry and Construction. This presentation is provided under the authority of Section 396-4C of the Hawaii Revised Statutes, which authorizes our division to disseminate educational information to employers, employees, and the general public. Through lectures, exhibition, and other forms of public outreach, we aim to raise awareness about the causes and prevention of workplace accidents and injuries. I'm your presenter, Edmar Castillo. I'm the HIOSH Compliance Assistant Specialist, or just Community Outreach. And I believe in educating, empowering, and collaborating with our community because when we invest in our community through knowledge, safety, and shared responsibility, then we create leaders who feel confident, capable, and committed to protecting themselves and those around them. If any are interested in strengthening our collective understanding of safety and health, then contact me to build a culture where everyone feels empowered to take action and support one another. And this presentation is for educational purposes only and is not a legal document. For full legal obligations, refer to official HIOSH laws and regulations at our website. We'll cover key points, but this presentation cannot include everything needed for a fully safe and healthy workplace. It's still the employer's responsibility to address workplace hazards and eliminate or mitigate them. The goal of this webinar is not to teach you how to avoid citations, as clearly I'm not an attorney and I don't offer legal advice. Instead, we aim to understand the HIOSH law and regulations better so we can protect our communities more effectively. First, we'll dive into First, we'll examine the fundamentals of fall standards. I'll discuss briefly the regulations that organizations must comply to meet the bare minimum. Next, we'll take a brief look at the hierarchy of controls in fall protection and how employers can use this framework to identify fall hazards and apply layered strategies to address them. Next, we'll explore what conventional fall protective systems mean per the standard. Then we'll review the requirements for a written fall protection plan, which is only allowed for certain types of work where conventional fall protection are not feasible or creates a greater hazard. Then we'll examine the non-conventional fall protection systems, focusing on when they may be used, what controls are needed, and how they fit into the overall strategies for managing fall hazards. Then a short Q&A at the end. And this presentation is designed with accessibility at its core, so my goal is to ensure that every participant, regardless of ability or background, can fully engage with the information being shared. And to support this commitment, I do want to note in advance that I will occasionally read directly from the slides, and this is intentional as some members of our audience may experience challenges with reading, vision, or other literacy related barriers. And by voicing the content, we help create a more inclusive environment where everyone can follow along. It's only when we can strengthen our community by supporting the people who struggle the most. Real progress begins when we notice who's being left out and make sure that they're included. Welcome to the fall fundamentals of fall standards. The remainder of this presentation builds on the employer's established training and procedures for protecting workers. Much of what follows should be familiar to those who practice this, but the goal is just to reinforce the practices and expectations for which employers should already know and apply. Are falls a problem? Absolutely. Across all industries, falls were the second leading cause of fatal workplace injuries. But in the construction industry, the picture is even more serious. Falls are the number one cause of worker deaths. And this means that more construction workers lose their lives from falls than from any other type of incidents. It's a clear signal that fall hazards remain one of the most critical safety challenges on job sites, and it underscores why strong fall protection practices, training, and planning are essential for keeping workers safe. Worker protection issues mostly came from human errors and equipment problems that created fall hazards, which the construction and general industry standards address. This includes where protection is needed to protect workers, how to select systems appropriate for situations, how to construct and install, how to properly supervise employees, how to implement safe work procedures, and training addressing the selection, use, and maintenance of the company's chosen systems. We're not able to address all within the hour, but I will address at least the first three. And these are the standards to address the common issues experienced by the companies regarding fall protection, like I mentioned earlier. And notice the similarities in both standards, well, except for the personal fall protection systems detailed under section 1910.140 for general industry. Uh, there is a duty in both general industry and construction, where it examines where protection is required, and a selection for fall protection systems. Criteria and practices addresses the proper construction and installation of the systems, as well as proper supervision. And finally, the proper training in the selection, the use, and the maintenance of fall protection systems is covered in the training requirements. And some tasks can fall under either general industry or construction, depending on what else is happening at the site. The simplest way to tell the difference is this. If the work improves or changes a structure or building, it's construction. If it preserves or keeps it in good condition, then it's maintenance and therefore falls under general industry. And as we talk about fall hazards, I'm talking about the threshold height that triggers the employer's obligation to provide fall protection. For general industry, it is 4 feet. Construction, it is 6 feet. But the commonalities in the definition of fall hazard for general industry and construction is fall into or onto dangerous equipment, regardless of the threshold height. And for example, that's like working 2 feet over a machinery with like open drive belts or pulleys or gears or open vats of like degreasing agents or acid that can seriously burn an employee. So these are the things that we consider. And both standards contain several exemptions. But one thing I do want to point out in both standards, the exemption for fall protection systems applies to those performing inspections, investigations, or assessments before work begins or after all work is completed. And historically, insurance companies told OSHA in their rulemaking of the standard that some tasks, like insurance inspectors, claims adjusters, and loss control personnel, for example, should be exempt because requiring them to use fall protection systems would, one, increase risk by requiring them to carry and install equipment, like your rooftop anchors. Two, prolong their exposure to fall hazards. And three, be infeasible when they cannot install anchors on buildings or structures that they do not own because it's belonging to their clientele. And OSHA continues to agree with this rationale as it does reflect real-world inspection practices. However, in general industry, this exemption does not apply when the fall protection systems are already installed on the structure of a building, like your rooftop anchors and self-retracting lifelines. Therefore, in those situations, inspectors are expected to use the existing equipment, and this expectation is increasingly practical as more and more buildings now incorporate permanent anchors, ladder safety systems, and other built-in fall protection features. In other words, workers don't have to use fall protection while they're just checking the site before work starts or after work is finished, unless proper fall protection systems are already installed and then made available. If the equipment is in place, then workers must use it even during inspections or assessments. Finally, we get to the application. In general industry, there are 16 situations where the conventional fall protection is the default method, with a few exceptions. I'll explain conventional fall protection systems shortly, but it's important to note that although many requirements apply to specific areas and specific situations, item number 16 serves as a catch-all for any fall hazard not otherwise listed. Also notice the logo that we saw from our first slide denotes the applicable area where HIOSH cited general industry previously is the unprotected sides and edges. In the construction standard for fall protection, there's about 15 specific situations, again defaulting to conventional fall protection systems with a few exceptions. And again, the logo from the first slide denotes employers in the construction industry tends to have an issue in the residential construction listed here. Starting with the principles for fall protection hierarchy of controls, where employers can learn and apply this layered strategy to design to prevent fall-related injuries by the prioritizing methods from most effective to least effective. So elimination is the most effective control, such that employers can redesign the work to remove the fall hazard entirely. An example would be like bringing work to the ground level by removing the need for workers at height, like doing ground level assembly, like constructing roof trusses, wall sections, or signages on the ground, then lifting the completed work into place with a crane. Another example would be for painters to use long handled rollers for painting a residential home or cleaning tools from the ground instead of using a ladder. Another is using drones or camera poles for inspections. There's so many creative options available to employers without risking their workers to not be near an unprotected edge or side. Passive fall protection systems are protective measures that are fixed in place and don't require human interaction or involvement to serve their purpose. An example of this would be physical barriers like your guardrails or parapets, safety net systems, those kinds of things. Active fall restraints systems are those that restrict workers' movements from preventing them from accessing fall hazards. Essentially, it's like a leash on the worker from going further to the unprotected edge. And this requires some level of worker participation, like donning body harnesses and connecting to anchor points on the rooftop. And unlike fall restraints, fall arrest is a reactive system designed to safely stop a worker mid-fall, limiting the fall distance and impact forces and preventing them from striking a lower level. And these are typically your full body harnesses with the shock absorbing lanyards. And finally is the administrative controls. This is where measures aimed at lowering the risk of falls. These are the least effective method because they don't really offer a physical or positive means of protection. That's where the conventional fall protection systems is not feasible because of certain circumstances that I'll explain later down in the slides. And one will need to address it usually with setting up lines and stanchions or other alternative methods. I've been talking about conventional fall protective systems, and this is what it is. It's three areas. The first three is guardrails. So if you're choosing to create your own guardrail, then there's specific regulatory criteria. The top rail must measure 42 inches plus or minus 3 inches from the walking working surface to the top edge of the top rail. And in practical terms, the acceptable height range is 39 inches to 45 inches. And if you're wondering why 42 inches was chosen, it's because the center of gravity for most workers is around their midsection. Therefore, a critical factor for top rail is that it contacts above workers' center of gravity, thus preventing them from pivoting over the guardrail. And that's not a foreign concept for a lot of these trade industries because the International Building Code, the IBC, and the International Residential Code, the IRC, has similar requirements requiring a 42-inch guardrail. Secondly, the midrail must be installed at a height midway between the top edge of the guardrail and the walking working surface. This tends to be about 21 inches if the top edge of the top rail is 42 inches. Finally, when installing the toe board, it must be measured 3.5 inch in vertical height with 1/4 inch clearance from the walking working surface. Also note that in Appendix B to Subpart M, there's about 5 types of railings and guidance that employers can consider using when designing a guardrail: wood, pipe, wire, rope, and structural steel. And when we want to test the strength of these railings, there are certain considerations. The top rail must withstand at least 200-pound force applied in any outward or downward direction at any point along the top edge of the top rail. This is because we don't want to deflect the top rail to a height of less than 39 inches, like I discussed about, above the walking working surface. And you'll notice when you read the standard, it is indeed a performance-oriented standard. Therefore, the employer has the flexibility to determine how to test the strength of the railings. For mid-rail, it's at least 150 pounds applied outward or downward, and at least 50 pounds for the toe board. When guardrails protect employees from falling, similar barriers must be also used to prevent objects from falling onto workers below. These protective measures can include screening or mesh, toe boards, or solid panels installed from the top rail or mid rail down to the walking working surface. And if you're choosing to create your own safety net, know that there's also criteria that needs to be met. In general industry standard, the safety net refers to the construction standard, so therefore a lot of the regulatory requirements come from this construction standard. You'll want to attach the safety net as close as possible to the walking working surface, but never more than 30 feet below it. Also, when connecting the net close to the surface, the border rope, that's the one that you use to connect the safety net to the fixed object, must have a minimum breaking strength of at least 5,000 pounds. And this is because when a worker falls, the force on the net is significantly higher than the worker's weight due to the momentum. It's also important to note the criteria elements for your webbing of your safety nets. The opening size of the net is the clear opening or the holes between the material. Determining the opening size is important because it controls on what stays on top and what falls through your net. The net openings in the mesh can't be larger than 36 square inches, and no single side of any opening can be more than 6 inches. The spacing between the ropes or webbing also has to stay within 6 inches from center to center. Every point where the mesh intersects must be securely fastened so the openings don't stretch or get bigger during use. Safety nets must extend outward from the edge based on the vertical drop. So, if the drop is under 5 feet, then the net must extend at least 8 feet. For a 5 to 10-foot drop, the net must extend at least 10 feet. For drops of 10 feet or more, the net must extend 13 feet or more. With it, safety nets and safety net installations must also be drop tested at the job site at these frequency after initial installation and before being used, whenever relocated, after major repair, and at 6-month intervals if left in place for far too long. The drop test consists of a 400-pound bag of sand, 28 to 32 inches in diameter, dropped into the net from the highest surface at which the employees are exposed to fall hazards, but not from less than 42 inches above that level. And when the employer can demonstrate that it is unreasonable to perform the drop tests, as mentioned earlier, then the employer or the designated competent person shall certify that the net and net installation have sufficient clearance and impact absorption by preparing a certification record prior to the net being used as a fall protection system. The certification must include identification of the net and net installation, the date that it was determined that the net and net installation were compliant, and signature of the person making that determination and certification. The most recent certification record for each net and net installation must be made available at the job site for inspection. Safety nets must be inspected for wear, damage, and other deterioration at least once a week, and after any occurrence which could affect the integrity of the system. You'll want to note possible deterioration caused by ultraviolet exposures if the net is installed outdoors, possible rot or mildews with the net. It might also be important to have flame retardant coatings on your net system, depending on your application. There's about several types of active fall protection systems currently available on the market, and probably more. And each varies based on the manufacturer and the specific applications an employer intends to address. I will not be covering these systems in detail during this because having a thorough discussion would probably exceed our allotted time, and it's best suited for another separate time, which I anticipate offering next year through our webinar. Fall Protection Plan. So the purpose of the fall protection plan is for the employer to document areas where conventional fall protection systems would be deemed infeasible or it creates a greater hazard in specific situations or tasks and create and therefore the employer must create an alternative method. In our area, we do see employers skip to the alternative methods without rationalizing and documenting if they can even use it. I'll explain that in a bit. The fall protection plan is required uh, and is only found in one, general industry standards where there's unprotected sides and edges, and two, in construction standards where it's found in leading edge work, precast concrete erection work, or residential construction work. Again, notice the logo from the slide where slide one refers to the most commonly cited by HIOSH this past fiscal year. And also notice in the general industry standard for fall protection plan, it relies on the construction standard when it comes to developing a fall protection plan. And to really hone in on this, it's important that employers follow the required decision-making process before using the non-conventional fall protection systems. In other words, please don't skip this process because the fall protection plan standard requires it. First, you want to identify the applicable workers and situation. Uh, if certain situations or tasks apply, like what I mentioned previously, then move on to the next step. Second, determine if the conventional fall protection systems would be feasible for your specific situation or task. Only if you can demonstrate that conventional methods are infeasible or create a greater hazard may you move forward. Third, develop a written procedure of the fall protection plan, which I'll talk about in the next slide. Once these requirements are met, you may implement the non-conventional fall protection systems. Again, the most common employer mistake is bypassing number two and number three and going straight to the non-conventional fall protection without the required justification and documentation. And to develop the fall protection plan is found in these categories. A written fall protection plan must be prepared by a qualified person. Quite simply, that they have some expertise to solve this infeasibility with non conventional fall protection systems, which the definition of the qualified person stems from the Hawaii Administrative Rules. This plan must be for specific job sites, kept current, and updated only with that qualified person's approval with a copy maintained on site. The plan must then be implemented under a competent person. That's simply one that has authority to identify hazards and correct them under the Hawaii Administrative Rules. That includes supervision, including documentation of why conventional fall protection is infeasible or creates a greater hazard, and what alternative methods will reduce or eliminate the risk. Controlled access zones, which I'll talk about that in a bit, must be identified whenever conventional fall protection cannot be used, with compliance to the standard, section 1926.502G. A safety monitoring system if required, again, I'll talk that in a bit, and a list of authorized workers. After any fall or near miss, the incident must then be investigated and the fall protection plan be updated to prevent reoccurrence. Okay, so this is now we're on the non-conventional fall protective systems. I do want to note this is considered the last resort, not the default method, but the last resort, because OSHA determined that there is no safe distance from an unprotected side or edge of a walking working surface that would render protection unnecessary. And this is important to note because unlike conventional fall protection systems, these do not provide equal protection to workers. So there are two types. Uh, Designated areas and safety monitoring system. Designated area is a delineation, usually by lines and stanchions. Safety monitoring system is someone watching you and warning you, hey, you're getting too close to the unprotected sides, or just crossing the delineated line, come back. And within the DA, or designated area, there's the warning line system and the controlled access zone. The difference between the two is simply the controlled access zone is restricted entry. Think of it like exclusive entry to the nightclub. You have to be on the list in order to get access to this. Versus the warning line system is a visual boundary. You can see the lines and stanchions to warn you if you're getting too close to the unprotected, to that area of the danger zone. So warning lines in construction are mainly used for roofing work on low slope roofs. Low slope roof is defined with a slope of 4 to 12 slope, not or less or fewer than that. In the general industry, they're used on low slope roofs as well as around repair, service, and assembly pits. In vehicle service and repair pits, the fall hazard is present only when a vehicle is not over the pit. Driving over the pit normally eliminates the fall hazard, and also conventional fall protection systems may not work at the service, repair, and assembly pits, mainly because guardrails interfere with vehicles over and away from the pit. The fall protection or the leash or the personal fall arrest systems prevent workers from reaching the area to perform work. So the general industry standard required in these pits, if less than 10 feet in depth, since fall protection is not feasible, is simply one, authorizing trained employees to enter within 6 feet of the edge. Two, mark off the area at least 6 feet from the edge with the use of contrasting floor markings, warning lines, or a combination of both. I don't have that pictured here because it's hard to find a free picture for warning lines and floor markings. And three, post caution signs with the words caution open pit to start. Also, you would see designated areas in general industry is dependent on the distance of work relative to the unprotected low slope roof edge. When working on a low slope roof, workers within 6 feet of the edge must use conventional fall protection, like I mentioned it previously. Any one of the three guardrails, safety nets, or the personable fall harnesses. If they are between 6 to 15 feet from the edge, they can use either conventional fall protection systems or the DA, the designated area. But the use of the DA is only when the work is both infrequent and temporary, which I'll explain in a little bit. At 15 feet or more from the edge, workers may also use conventional fall protection or the DA or just no fall protection if work is infrequent and temporary and a work rule is implemented and enforced prohibiting workers from entering within 15 feet of the roof edge without fall protection. And this mirrors closely to the numerous feedback that OSHA received regarding the construction standard on warning line systems. Now, you might be wondering, what does the infrequent and temporary mean and how it's defined? There's no regulatory definition. However, in the preamble to the standard, I'm sure because you guys are lawyers, you already know what preamble is, but just for the record, it's the detailed information about the background, purpose, and justification of the regulations federal agencies promulgated. Infrequent simply means task done occasionally, monthly, yearly, or as needed, but definitely not daily or routine. However, I do want to state that if, say, the HVAC technicians, the people that do the ventilation and or AC, if their primary duty is going to multiple job sites to perform simple tasks every day, then he or she is still exposed to fall hazards daily, and therefore does not qualify for infrequent definition. The frequency is evaluated per individual worker, not per job site. Likewise, temporary means short tasks that take less time than setting up the fall protection systems, or just, less than 1 to 2 hours to complete a temporary task. And if you recall, to use the exemption in the standard, the task must meet both conditions, infrequent and temporary. Therefore, if a task meets only one of these criteria, then the employer cannot claim the DA option for work performed 6 to 15 feet of the roof edge, nor can the employer claim that no fall protection is an option for them if working at 15 feet or more. In other words, at that category, the employer has to use any of the prescribed fall protection methods. So this chart is designed to help users determine which fall protection systems apply based on their work distance from the roof edge and whether the work is infrequent or non-infrequent, temporary or not temporary. As the chart moves from green to red, the red sections indicate situations where employers must apply a greater scrutiny, especially if they intend to use a designated area or are considering working without any fall protection systems with a work rule, of course. Another side note, there's an important difference between the what I mentioned earlier in the slides, inspection exemption, and the no fall protection option for work on low slope roofs in general industry. While both situations may allow work without fall protection, they apply in completely different ways. So, under the inspection exemption, both general industry and construction allow workers to inspect the work site before work begins or after all work is completed without fall protection. Because if you recall, setting up a fall protection would take longer and create more exposure to the hazard. However, this exemption does not apply in general industry if the compliant fall protection systems are already installed and made available, like your rooftop anchors and your self-retracting lifelines. However, the general industry's low slope roof standard allows no fall protection as one of the three options, but only when the work is infrequent and temporary, the worker works at least 15 feet from the edge, and there's an established work rule preventing entry into the 15-foot zone without fall protection. These are two separate fall protection concepts, and it's important not to mix them up. We don't want workers to skip the fall protection when it's required, or misclassify the work task, or enter that danger zone without the safeguards necessary to protect them. Inspection exemption is for quick, low risk checks away from the edge, whereas in general industry, low slope rule manages risk based on the distance, the frequency, and the task duration. So in the construction, warning lines are just for roofing work on low slope roofs. And roofing work is defined to mean hoisting, storage, application, and removal of roofing materials and equipment, including related insulation, sheet metal, and vapor barrier work, but not including the construction of the roof deck. A warning light system must use strong visible materials and must be set up so workers can clearly see and feel it as a boundary. The line must be made up of rope, wire, or chain and must have high visibility flags spaced no more than 6 feet apart. It must be positioned between 34 and 39 inches above the roof surface. The height is low enough to warn a short worker topped over, while at the same time, it is high enough to not be a tripping hazard. The line must be strong enough to withstand at least 200 pounds of force and at least 500 pounds in construction. The stanchion's supporting line must be 30 inches tall and be able to resist at least 16 pounds of horizontal force without being tipped over, since a worker might back into the line or approach it without paying attention. When setting up a warning line system, it has to be installed around every side of the roof area, and the distance from the roof edge depends on whether the mechanical equipment or ME is being used. ME includes any motor or worker-powered wheeled equipment used for roofing work, except wheelbarrows and mop carts. We focus on ME because the highest risk occurs when the equipment is turned around. Workers often shift their attention away from the edge and make awkward movements, sometimes stepping backward toward the edge while trying to reposition this heavy, clunky machine. The required 6-foot and 10-foot distances are designed to give workers enough time to notice the warning line and stop before getting too close to the edge, which is especially important in roofing where workers may move backwards while applying materials. And if you're wondering why wheelbarrows and mop carts are excluded from the ME definition, like I mentioned earlier, it's because they don't require backward movements, are lightweight, and they don't build up momentum. So they don't really pose the same level of risk as these heavier equipments like the felt layers or gravel buggies that you see pictured here. Controlled Access Zone, or CAZ, is defined as an area in which certain type of work may take place without the use of the conventional fall protection systems, and access to the zone is controlled. That's the exclusive nightclub where you have to be on the list to enter. And you will only see CAZ used in conjunction with fall protection plan in specialized construction work like overhead bricklaying, leading edge work, and residential construction work. The criteria to install CAS is similar to warning lines, except the difference is the highest point of the control line must be no more than 45 inches from the walking working surface, as opposed to 39 inches, 50 inches for overhand brick laying. Another important thing to note is that CAS can be connected to either guardrail system or a wall, whereas warning line system is all around the sides of the roof. The control line must be placed 6 to 25 feet from the leading or unprotected edge, and it must run full length parallel to the edge and connect to each side of the guardrail or wall. That last one is to ensure that there's no gap between the coverage of the CAS and that of the fall protection required for other areas of the work zone. I do want to remind that all workers working outside the CAS must be using conventional fall protection systems if exposed to fall hazards. As the CAS moves, meaning it moves forward as the work progresses as the leading edge, it exposes unprotected sides and edges perpendicular to the leading edge. The fall protection is necessary, especially when two groups of workers are working on the same level, and one group is working in a CAS and the other group is being protected by conventional fall protection systems. However, for the erection of precast concrete members, the CAS line must be no closer than 6 feet, no farther than 1 feet of the size of the precast member being erected, to a maximum of 60 feet, whichever is lesser. And this exception is because sometimes it is necessary to turn a precast member, which may be as long as 120 feet. And if the control lines are too close, they could become entangled or uprooted as the concrete member is being positioned. So, if a precast concrete member is 40 feet in length, then half of 40 is 20 feet, which is indeed lesser than 60 feet. CAS for bricklaying and related work is within 10 feet from the unprotected sides and edges. This number was established with extensive review with other industry and union representatives to provide overhand bricklayers with an area free of interference from other employees not performing the overhand bricklaying and related stuff from being in the CAS. A safety monitoring system is a verbal warning system. If you recall, warning line system is visual, safety monitoring is verbal. They will yell at you. The safety monitoring systems uses a competent person as a safety monitor who has the authority to warn workers that they're getting too close to the unprotected sides or edges or crossing the delineated line. The competent person must be able to stay on the same level as the workers he's watching, maintain visual contact, be able to communicate orally to nearby workers, and only watch workers and not have any responsibilities. You are strictly watching the workers that you're supposed to be watching. You cannot do any other work or be distracted by any other work because your only job is to watch employees from crossing the line. Other consideration when using safety monitoring systems is like I talked about for mechanical equipment, ME, while you're using the safety monitoring systems, you can't store or use ME for roofing work on low slope roof. Two, OSHA believes that the presence of the extraneous employees in these areas can interfere with work procedures necessary for the effective use of safety monitoring systems. Again, the main job of the safety monitor is just watch. Any other people might divert their attention away from what they were supposed to do. And three, those permitted in doing work in safety monitoring systems areas comply with the directions from them to avoid fall hazards. In other words, listen to the safety monitor. They're the competent person. They will yell at you if you get too close. Obey what they say. Okay? And that is fall protection fundamentals in a nutshell. I have an anonymous survey available. If you wish to make this session be made available in person, longer session, cover more of the regulations, or host it frequently, help me complete our anonymous survey. Your survey provides us data that there is a demand and growing interest in our community to host more. And please note, I am teaching other areas. Here's the curriculum lineup. Registration for June and July webinars will be posted on our website in about a couple weeks before each session. And that I hand it over to the Hawaii State Bar Association for this. Thank you very much.
Thank you, Edmar. If anyone has any questions, please put them in chat. We'll read it out loud for Edmar to answer. For those that have experienced any audio issues during this presentation, we do apologize. But we will make this recording available later in the week or sometime early next week. So
Oh, I
and then
apologize. Was there an audio issue on my end?
um. Well, we haven't really deducted where the audio issue is coming from, but
Oh,
yeah, so but the record I'll take a look at the recording, and if it's good, and if it's good, I'll post it to our webpage. So yeah, so just be on the lookout if you haven't if you have issues with audio, we'll look out for the recording of this presentation later this week or sometime next week. But yeah, is there any questions that you would like to ask Edmar in the chat? No, I don't see any questions, but
Edward, I got one kind of maybe off the topic, but can you talk to the extent can you talk about, I guess, if there's any suspected complaints or violations regarding fall prevention and the regulation you just talked about? What can people do?
oh, okay. So if they want to file a complaint, is that what I'm getting the gist?
Essentially, or you can describe the complaint process, if there's a suspected violations or concerns, what will be the steps, someone should take?
Oh yeah. Yeah, definitely. Sorry, I guess I was just mentally focusing on the fall protection. But yeah, procedurally, they can just contact our office or go on our website. We have an online form made available for folks who want to file, especially if they want to file anonymously. Although we would love to have people submit their names and phone numbers in case we have additional questions like where exactly, what island. There's some information missing to help us really gauge what's the context of the work going on. So uh, I wish I remembered I'm blanking out right now, but the phone number and but simply just go on our website where it has more extensive information about what's required to submit your complaint, whether anonymous or not anonymous. And what we get is if it's submitted online, which is through the federal OSHA website, it'll be triaged down to us, down to the state level for us to address it.
It looks like there's no questions, so in the chat room, but I guess, Jared, you wanna close this up?
Yeah, so with that, thank you, Edmar, for a really good, informative presentation. And I want to thank everyone else for joining us for today's coffee hour, and we look forward to, I guess, hearing from all everyone next month, first week of
June
June
4th.
June 4th, sorry, at noon, at 12 p.m. Thank you, everyone, and aloha.
Alright, thank you.
Aloha. Mahalo.